Ever wondered about the incredible journey of water? Welcome to Class Bites. Today, we're diving deep into the amazing hydrologic cycle that makes life on Earth possible. Our planet is awash with water, a substance so common we often overlook its extraordinary journey. The story of water is a tale of constant motion, a perpetual pilgrimage from sky to earth and back again, known as the hydrologic cycle. This grand planetary system, powered by the sun's energy, connects the lands, oceans, and atmosphere, making life itself possible. The study of this journey, in all its forms and locations, is the essence of hydrology, a science that seeks to understand the origin, distribution, and properties of this vital resource. The Earth's water is overwhelmingly salty, with the vast oceans holding more than 97% of the total supply. This leaves a mere fraction as freshwater, the lifeblood for terrestrial ecosystems and human civilization. Of this small freshwater portion, the great majority is locked away, frozen in glaciers and immense ice sheets. Most of the remaining liquid freshwater is hidden from sight, residing beneath the ground. Only a tiny sliver of Earth's water flows in the familiar forms of rivers and lakes, yet these surface waters are profoundly important to the world we know. The water cycle has no true beginning or end. It is a continuous loop. We can, however, begin its story in the great expanse of the ocean. Warmed by the sun, surface water transforms into an invisible gas, water vapor, and rises into the atmosphere in a process called evaporation. The oceans are the primary engine of this process, accounting for the vast majority of moisture that enters the air. Plants also contribute, releasing water vapor from their leaves in a process known as transpiration. As this moist air ascends, it cools, and the water vapor undergoes a transformation. It condenses back into minuscule liquid droplets or ice crystals, gathering together to form the clouds we see drifting across the sky. These clouds are atmospheric travelers, carrying water far from its source. When the droplets or crystals grow heavy enough, gravity beckons them back to the surface as precipitation, rain, snow, or hail. While most precipitation falls back into the ocean, a significant amount lands on the continents, replenishing the land. Once on the ground, the water's journey continues along several paths. Some of it flows across the surface as runoff, gathering in channels and depressions. This is the birth of rivers, dynamic conduits that collect water from a wide area and guide it on its inevitable course back to the sea. Rivers are powerful agents of change, carving canyons, shaping valleys, and carrying not just water, but also dissolved minerals and nutrients that enrich the land. Along their journey, they may pause in lakes, which are essentially wide, slow-moving parts of a river system, acting as temporary storage basins. These freshwater bodies, both rivers and lakes, are critical hubs for life, providing drinking water and essential habitats. Not all precipitation runs off the surface. A portion soaks into the ground, seeping through soil and porous rock in a process called infiltration. This water becomes groundwater, a vast, hidden reservoir that fills the tiny spaces between particles of sand and gravel and the fractures in solid rock. This subterranean water exists in saturated zones known as aquifers. Far from being static underground pools, groundwater is in constant, albeit very slow, motion, often flowing towards and feeding into rivers, lakes, and springs. It represents the largest store of unfrozen freshwater on the planet and is a critical source of drinking water for a huge portion of the global population. Eventually, whether through the winding path of a river or the slow seepage of groundwater, the water returns to the ocean, completing the cycle. But the ocean itself is not a still basin. Its waters are in constant, large-scale motion through a system of ocean currents. These currents act like enormous rivers within the sea, driven by winds, the Earth's rotation, and differences in water temperature and salinity. Surface currents, often pushed by prevailing winds, can move water across entire ocean basins, profoundly influencing weather patterns. For instance, warm currents can make coastal regions more temperate than they would otherwise be. Deeper in the ocean, a slower, density-driven circulation, known as the global conveyor belt, moves immense volumes of water, transporting heat from the equator toward the poles and playing a vital role in regulating the planet's climate. These currents are also essential for marine life, distributing nutrients and oxygen throughout the deep sea. From the smallest raindrop to the mightiest ocean current, water weaves a continuous story of movement and transformation. It is a cycle that distributes energy and resources across the globe, sculpting landscapes, regulating climate, and sustaining the rich tapestry of life. The rivers that flow, the lakes that shimmer, the hidden groundwater, and the restless ocean currents are all interconnected chapters in this epic narrative, a cycle that defines the very character of our living world. Thanks for watching. Please like, subscribe, and comment with your thoughts or future topic ideas below.